Hello, guys. Welcome to Ramita Solutions and welcome to your grade 12 mathematics. We are looking at differentiation calculus. So today we are looking at past papers, and in the past paper, or rather a past paper that we're looking at is the paper that was written by the Gauteng province in September 2023. Victoria. So now let's open the paper and get our distinctions. So here's the paper. I'm going to pin it. Okay, it's pinned. Now let's go. Okay, so before we proceed, I want to read instructions, and if you are using a mobile device, please guys, rotate your screen so you have the best viewing. Okay. All right, so instructions. I'm going to read some of the instructions. Instruction number 3. Clearly show all calculations, diagrams, graphs, etc. that you have used in determining the answers. Okay, instruction number 4, answers only will not necessarily be awarded full marks. Instruction number 6, if necessary, round off answers to 2 decimal places unless stated otherwise. Now, guys, all the instructions are important. However, I'm choosing those that I want to highlight or I want to use in this video. Okay, this one where they say clearly show all calculations, diagrams, graphs, etc. that you have used in determining the answers. For me, it's very key because as students, you tend to focus your answers in a certain format when there's more than one way of giving your answers. Okay, you are not restricted unless they say to you using a certain technique, then you can say, okay, I have to use this one and not that one. But otherwise, you must show all calculations, diagrams, graphs, etc. that you have used in determining the answers. And this is what the Department of Education is about, to empower you to be academics, to be experts. Okay? All right. Okay, so without any waste of time, let's get into our questions. Normally, differentiation calculus is starts in question 7 or question 8. Let's see where it starts in this particular question paper. Okay, it seems like it starts at question 8. Here is it. It starts at question 8. Okay, perfect. So, remember, if you're using a mobile device, please rotate your screen. All right, let's go. Question 8. So, question 8, it says, 8.1, determine f prime x from first principles if f of x is equal to 3x squared minus 6. Let's go. So they say f of x is 3x squared minus 6. Now what is f of x plus h? Remember, first principle. So it is 3, where there's x, you will put x plus h, of course, close square, minus 6. This becomes 3, open bracket. The bracket becomes x squared plus 2xh plus h squared close minus 6. Further, this becomes 3x squared plus 6xh plus 3h squared minus 6. And by the way, before you proceed, when this question says using first principles, so you know you can get your answer using differentiation rules. When you use differentiation rules, know that f prime x will be 6x. If, guys, at the end you are not getting 6x, there is a mistake that you made. So now let's get into it. F prime x is equal to the limit as h tends to 0. Okay, of what? Of f of x plus h minus f of x all over h. Remember, guys, this formula is given in your formula sheet. Okay, let's go now. The limit as h turns to 0 of what is f of x plus h? It is 3x squared plus 6xh plus 3h squared minus what is f of x? I'm going to put it in a bracket. It'll be, oh, I forgot minus 6. Minus 6. Now, what is f of x? I'm going to put it in a bracket. It is 3x squared minus 6 all over what? All over h. Okay, all over h. Happy? Perfect. Now let's go to the next page. Going to the next page, you can see 3x squared will cancel with 3x squared, minus 6 will cancel with minus 6. So what are we left with? It'll become the limit as h tends to 0 of what? Of, was it 6xh? 6xh plus 3h squared. 6xh plus 6, is it 6 or 3? 3h squared. I think it's 3h squared. Let me confirm. Yes, 6xh plus 3h squared all over h. Okay. Now we will take a common factor here. Common factor, yes, it looks like it's 3h. There's no need to say 3h because the h's will cancel with the denominator here. So let's rather say h is a common factor. So the limit as h tends to 0, take h out as a common factor. What are you left with? You're left with 6x plus 3h close all over h. As you can see, h cancels with h. Now we have the limit as h tends to 0 of 6x plus 3h. Now you can substitute whether's h, you can put 0. Remember, we couldn't do that earlier because if you put whether's h, if you put 0, this will become impossible because your bracket will be 0. I mean, your denominator will be 0, and this will be impossible to work with. Okay, so now we can substitute whether's h, we put 0. Sorry. So when we do that, we have to drop the limit. Now this becomes 6x plus 3, open bracket 0, close. This becomes 6x. Like I said, this is what I am expecting. And indeed, I got it. So it means we are correct. Okay, it means we are correct. Moving on. 8.2. 8.2 says determine the derivative. Determine the derivative of this fraction here. They say f of x is equal to, open bracket, 2 square root of x minus 1 over x to the power 2. Let me simplify this and say this becomes 2x to the half minus x to the minus 1 all square. What is this? This will be, I think, to be safe, this will be, let me just do it like this. It'll be 2x, okay, 2x to the half minus x to the minus 1 times 2x to the half minus x to the minus 1. So this becomes 4, oh boy, this becomes 4, oh boy, 4x, half plus half becomes 1. It's okay, so it's 4x. And then this is what is half times half minus 1. It becomes minus half. So this will then be minus 2x to the minus half. And this is also minus 2. This also becomes minus 2x to the power minus half. And what is this? This is negative times negative is positive. Now minus 1, it becomes negative 2. Okay, it becomes negative 2. So further simplification, this is 4x minus 4x to the power negative half, right? To the power negative half plus x to the power negative 2. Now we can find the derivative. The derivative is f prime x. What is it? F prime x will be 4. Okay, it'll be 4 minus 4 into minus half. I want to do this so that we don't make any mistakes. And then x to the minus half minus 1, it'll become minus 3 over 2. Now this is minus 2. X to the minus 3 minus 1, minus 2 minus 1, it'll become minus 3. Therefore, f prime x is 4. Negative times negative is positive. 4 times half is 2. So 4 plus 2x to the power minus 3 over 2 minus 2x to the power minus 3. Okay. All right. So this is it. Okay, guys, this is it. Let's see if we made any mistake. I don't think we made any mistake. Let's see. Oh, yes, we didn't make any mistake. We are okay. So we can proceed. Okay, we can proceed. All right. Perfect. Okay. Now let's head to 8.3. 8.3 says, you are given this guy here. Determine the interval for which this guy is concave up. Right? For him to be concave up. Remember, this guy is a parabola, or rather, not a parabola. Sorry. He's a cubic function. Okay? He's a cubic function. As you can see, coefficient of x cubed is positive. That means he ends with a smiling face. As you can see, he ends with a smiling face. Now, they say determine the values of x for which this guy is concave up. Right? For which this guy is concave up. Now, let's go. So, for him to be concave up, remember, we have drawn this. So, let me just say, without any waste of time, let's do this. I'm going to explain this later. So, let's just say f of x is equal to 3x cubed minus 3x squared plus 6x minus 2. What is f prime x? F prime x is 9x squared minus 6x plus 6. Now let's look for second derivative. Second derivative is 18x minus 6. Now we need to equate second derivative to 0. It will be 18x minus 6. So 6 equals 18x. Therefore, 1 over 3 equals x. Now remember, guys, f of x is like this. Okay, f of x is like this. So where is it concave up? Where is it concave up? So we say this point here is your point of inflection. This point here is x equals 1 over 3. So where is it concave up? It is concave up when, hear me out, it is concave up when x is greater than 1 over 3. As you can see, this is concave up. So we'll say f is concave up when x is greater than 1 over 3. Let's do this. I want to get the mark on occasion as well. 4 marks. When x is greater than 1 over 3. Okay. Otherwise, you can also use second derivative test. So what you do, you will need to factorize this, find the roots, the critical points rather, find the critical points, and then after finding the critical points, you will substitute them either here, you will substitute them here to determine where you have your maximum and your minimum, and then you're good to go. Okay. Otherwise, this is what we do. Okay. Otherwise, this is what we do. All right. So this is our answer. Okay. Perfect. Now, this was the last question. Okay, cool. Now let's go to the next question. So we go into question 9. So question 9 says, sketched below is the graph of f prime of x, or f prime. The derivative of f of x is equal to negative 2x cubed minus 3x squared plus 12x plus 20. Points A, B, and C are intercepts of f prime with x's. I think there's a mistake here. Sketched below is the graph of, they should have said sketched below is the graph of f prime, comma, the derivative of f of x equals. Now that makes sense, okay? The derivative of, all right, cool. So it was a mistake. Of course, this was taught by human beings, so it was a mistake. The language was fixed. It's okay. Now, let's see. Points A, B, and C are intercepts of f prime with the axis. Write down the coordinates of A. Write down the coordinates of A. Well, I can already tell you that the coordinates of A are 0 and positive 12. Okay, I can already tell you that they are 0 and positive 12. Okay, that's what I can tell you. Immediately, I can tell you it is 0 and positive 12. Okay, but I have to show you why I'm saying that, right? So remember, this is the graph of f prime. So we can say this is 9,1, 9.1.1. First derivative f prime of x is, what is this? Negative 6x squared minus 6x plus 12. As you can see, this is the constant. F prime of 0 is negative 6, right? So what is this? This is positive 12. Therefore, A is 0 and positive 12, right? You guys can see it. Remember, this guy here is f prime x. And this point here is when x is equal to 0. Happy? Perfect. Now, 9.1.2, they say, determine the coordinates of B and C. Now, to find these coordinates, remember that x-intercepts of your first derivative are x values of your critical points or your stationary point. Okay, so let's go. We will say first derivative of x equals negative x squared minus 6x plus what? Plus 12. Okay, plus 12. Oh, sorry. They say determine the x coordinate or the coordinates of B and C, so it's fine. We will just say x-intercepts of this guy. Okay, so what do? It means here we equate first derivative to 0. What is this? But what I said is still okay, guys. It's still true. It's still true. So this is negative 6x squared minus 6x plus 12. So we can say this is x squared. This is x squared. Oh, come on, buddy. What are you doing now? Okay, this is x squared plus x minus 2 equals 0. So this is x minus 2 and then x minus 1 equals 0. So this positive must be positive 2. Therefore, we can say x equals negative 2 or x equals positive 1. Therefore, one that should have a negative value is this one here, point B. Its coordinates are, okay, let me write it in the next page. Its coordinates should be negative 2 and 0, and this one will be 1 and 0. Let's go. So B is negative 2 and 0, and then A is 1 and 0. Okay, A is 1 and 0. Remember, guys, x-intercepts of your first derivative is your x are the x values of the critical points of your cubic or your original in this case. Okay. 9.1.3. Which points on the graph will have the same x values as B and C? They are saying what we said. So these are the stationary points. Otherwise, you can call them turning points. It's okay. All right. Stationary points. All right. Stationary points. Remember, they're saying which points on the graph of f will have the same x values as B and C. It is the stationary points, or what you call the turning points of your f of x. Okay. It's still okay to say turning points as well. 9.1. Let me say, or turning points. Maybe let me force it, or you can also say turning points. It's okay. Okay. Now 9.1.4. 9.1.4. For which values of x will f be increasing? So you want to know where x will be increasing. this is basically to say where you're saying this is where f of x, f prime x will be greater than 0. Now guys, this is something that you already know what these values are, right? You already know what these values are. So you can say this is when, you can say, because you know it, it's given here, you can say this is when x is greater than, what is this value here? -2. And what is this value here? 1. Okay. Or let me give you some option 2. Okay, I shouldn't even say option 2. In case you're doubting it, this equation here will give you something like this. I want you to look at it. It'll end with a frowning face, right? It'll end with a frowning face. As you can see, this point here is x equals -2. This point here is x equals 1. As you can see, can you see that? As you can see, here, the f will be decreasing. Same applies to the right of this point. It'll be decreasing because when x increases, y decreases. But look at this. As you move from -2 to +1, it is increasing. Do you guys see that? Exactly. So this is where your 3 marks are coming from. Okay. All right. Otherwise, you're not going to be penalized for coming directly to here, because this is the information you have from this. Okay, this is the information you have from this. You already gave this point to be -2 and this point to be +1. Okay, perfect. Proceeding. Determine the y-coordinate of the point of inflection. Ooh, y-coordinate of the point of inflection. Interesting, but easy. 9.1.5, remember, you can find point of inflection by either finding the midpoint of these guys, right? Midpoint of the x values of these guys, okay? Or you can find second derivative. Let's remind ourselves, second derivative will be, let's go back to check. Second derivative will be, it will be -12x minus 6, right? It'll be -12x minus 6. Now, second derivative should be equated to 0. Now, what do you get? -12x minus 6, right? What is this? We have, let's see, we have +6, or not +6, we can say 12x equals -6, therefore x equals -half. This is x value of your point of inflection. Therefore, you need to look for f of -half. What is it? It is -2 into -half cubed, okay? -3 into -half square, plus 12 into -half, plus 20. Now let's get this value. Okay, let's get this value. -2 into 0.5, or -0.5. -3 into -0.5 plus 12 into -0.5 close plus 20. So what are we getting? We are getting 27/2. Okay, so this is it, guys. This is the y-coordinate of the point of inflection of f. Okay, this is it, and you get all your marks. Okay, you get all your marks. All right. Now let's head to, not done. Now let's head to 9.2. So 9.2, they say, okay, I have to go to the next page. And by the way, 9.2, guys, it was removed. Okay, it was removed. Okay, 9.2 was removed. They say the tangent at P with coordinates 3 and -10, or rather the tangent at P with coordinates 3 and -10 to the curve is given by that. This tangent intersects the x-axis at point R. Okay, line PT is drawn perpendicular to the x-axis with t on the x-axis. Determine the length of RT. Okay, determine the length of RT. So guys, this question was removed. I repeat, this question was removed. Okay, so I want you guys to see this, that this is your normal. I don't know if I should do it or I shouldn't do it, but I'm telling you right now, it was removed. But we can get this thing, the tangent, the length of RT. Okay, we can get the length of RT. So I'm going to do this. This is, I want you to see it now. So this is y equals minus x squared minus 1. So you are imagining this. Okay, you are imagining this. Y, x, I'm going to say 0, 1, 2, 0, 1, 2, something like that. And I see that I also have to, okay, I must also go to 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something like that, okay? Something like that. Okay. So we have, normally this is 0 and 0, but then it goes 1 unit down. Okay, it goes 1 unit down, and then it is 1 and 1, but then it goes 1 unit down. All right, so it's going to be minus 2, and then it's 4. It's 2 and 4. All right, it's 2 and 4, so it's going to be at minus 5, something like that. Okay, so this will be something like that. I'm not sure, but something like that. Okay, it'll be something like that. And then they say that we have the tangent to this graph at this point. Let's say, I'm not sure if I will do justice here. Okay, at this point, let's say it's somewhere here. So let's say this is your tangent here. Okay, so they say this tangent, it intersects the x-axis at point R. Now, okay, I don't want to do anything silly right now at point R. Now, note something. It intersects the x-axis at point R. Now, line PT, this is P. Okay, this is point P. Line PT is drawn perpendicular to the x-axis. Perpendicular to the x-axis. Ooh, do you see this? This is PT. It's perpendicular to the x-axis. Okay, it's perpendicular to the x-axis. Okay, so it means this here, line PT is drawn perpendicular to the x-axis with T on the x-axis. So this is point T. Okay, what is it? It is 3 and 0. This is point T, which is 3 and 0. Okay, cool. Now, determine the length of RT. Guys, remember RT is this guy here. I don't know where it's passing. I don't know where it's cutting. I don't know where it's cutting the x-axis, nor where it's cutting the y-axis. So I'm quickly going to say we can find gradient at this point. Okay, we will do it either way. So we'll say gradient at P with coordinates 3 and minus 10. What is it? It is, what is it? It is dy dx, or y prime, is equal to negative 2x. Okay, but this therefore says where there's, because it's gradient at a point, it says where there's x, we must put positive 3. So what is this gradient? It is positive 3, right? It is positive 3. So this is negative 6. This is now gradient at, it is now gradient at this point. Now we need to find equation of tangent. Okay, now we need to find equation of tangent. We now found gradient of the tangent. Equation of tangent. Okay, equation of tangent will be, I'm going to use gradient 0.4. Y minus y sub 1 is equal to gradient into x minus x sub 1, close. The point given is point P. The point given is point P with coordinates 3 and negative 10. So where there's x sub 1, we put 3. Where there's x sub 2, we put negative 10. So this is y minus 10 equals negative 6 into x minus 3. Okay, going to the next page. We have y plus 10 equals, let me confirm, negative 6x plus 18. Negative 6x plus 18. So y equals negative 6x plus 8. Okay, so we know the y-intercept of this guy. Unfortunately, with that diagram that I was trying to show you, it will not reach 8, but I'm going to show you now. Let's get the x-intercept of this guy. I'm going to use, so now x-intercept of tangent. Okay, x-intercept of tangent, it will be 0 equals negative 6x plus 8. 6x equals 8. This is what? This is 8 over 6 will be 4 over 3. It will be 4 over 3. Okay, 4 over 3. So 4 over 3 is 1,33, guys. So it's somewhere here. So this guy will be passing this point here, and boom, to, let's say, not negative, to y-intercept is 8. Okay, it'll be passing here. What is here? This is 4 over 3. Right? This is 4 over 3, which is 1,33. Okay. Now, what is this point? This point here is point R. Okay, this point here is point R. So what is point R? Point R is 4 over 3 and 0. Now, this question is asking us to find the length of RT. So I understand why they had to cancel this question, because it doesn't amount to 5 marks. So now we have to find the length of RT. What is this? It will be, now, therefore, RT will be, what is this? It will be, we found this guy to be 3. So 3 minus 4 over 3. Is it minus? Yes. So it's 3 minus, isn't it? It's 3 minus 4 over 3. What is this? This is 5 over 3. 5 over 3, guys, is equivalent to 5 over 3. 5 over 3 is equivalent to 1,67, I believe. Let me confirm. 5 over 3 is equivalent to, yes, it's equivalent to 1,67. So this is it. Okay, this is it. By the way, guys, remember I said this question was cancelled, but this is how you can do it. Okay, this is how you can do it. Okay, this is how you can do it. So I understand why it was cancelled. This was a lot of work for 5 marks. Right? This was a lot of work for 5 marks. So yes, it was cancelled, but otherwise, this is how you could have done it. So let's see if, I think this question ends here. Let's see. Oh yeah, no, it doesn't. Now we need to head to question 10. We need to head to question 10. Now let's check what question 10 is saying. It says the profit W of X earned by a company to manufacture X bicycles per week is given by, let's see, W of X is equal to X cubed or negative X cubed. By the way, negative X cubed over 150 plus 3x squared minus 250x minus 27,000. So this is the profit equation, okay, where X is number of bicycles per week. What should be the weekly bicycle production, or what should the weekly bicycle production be to be maximum profit? Guys, as you can see, this is a cubic function, right, with coefficient of X cubed negative. So it ends with a frowning face. So for it to be a maximum, you are looking for this value here. Okay, you're looking for this value here. Otherwise, we will do second derivative test. Okay. Ooh, what did I do now? Oh, okay. I have to go back. Okay. Otherwise, we will do second derivative test. Okay. Otherwise, we will do second derivative test. Now, let's find W prime of X. What is W prime of X? It is negative 3 over 150 of X, negative 3x squared over 150 plus 6x minus 250. Now this W prime, because it's maximizing of profit, we equate it to 0. It'll be negative 3 over 150 times x squared plus 6x minus 250. Okay, so let's see. Let's see what we can do here. So what we need to do here is simply to say, let me see. I'm going to divide 6. I'm going to divide it by negative 3 over 150. What do we get? So this is 0 equals x squared minus 300x, and then 250, or negative 250 divided by negative 3 over 150. It gives us positive 12,500, isn't it? Positive 12,500. So this we can factorize. It seems like we will say this is x minus factors of 1250. Product will be 250 and 50. Let me see. 250 and 50. So yeah, they are okay. Negatives. Therefore, we will say this is when x is equal to 250, or this is when x is equal to 50. Now remember, guys, let me show you now. These are the values that we got. I told you that the coefficient of x cubed is negative. This means it's ending with a frowning face. So it's ending with a frowning face. It means this guy here is 250 and this guy here is 50. Therefore, maximum, bicycle production. So the bicycle production of 250, bicycle production of 250 bicycles per week, of 250 bicycles per week. Okay. Weekly bicycle, okay. I'm going to rephrase this. I don't want to be writing a lot of things. So weekly bicycle production. So weekly bicycle production of 250 will produce maximum profit. Okay, it will produce maximum profit. Okay, it will produce maximum profit. Remember, when it's concave down, this point is your, when it's concave up, this point here is your minimum. When it's concave down, this point here is your maximum. Otherwise, guys, you can use second derivative test. Okay, otherwise you can use second derivative test. So with the second derivative test, on the second derivative equation, where there's x, you will substitute these guys. If you get a positive, you will get a minimum. If you get a negative, you will get a maximum. Okay, remember, if you substitute these guys on the second derivative of your equation. Okay, otherwise, this is it. This is all that you needed to do in your Gauteng examinations. Oh, since you guys are now in grade 12, this is all they needed to do. Okay, guys, so we have come to the end of our lesson, and as is the case, if you have enjoyed this lesson, please subscribe, and you can also like and share with your classmates and everyone who might be in need of this. And if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. On our website, you will see these links, including WhatsApp link, or rather these icons, including WhatsApp icon. Click on any of them if you want to get in touch with us. Okay. And of course, your social media channels, you can follow us. So with that being said, ours ends here, guys. And all the best in your studies. Bye.